Hi and welcome back everybody. This is Miss Glink, and for this video we are going to work on reviewing how to round numbers. So I know it's been a really long time since we've worked on rounding, since the beginning of the year, but I think it's a really great way. Hopefully this will get those cobwebs out of that part of your brain and really just to help to review what skills we've done in the past. So to start off with, I'm going to give you a 1 or 2-digit number. Let's look at 39. So I know that my rules are that if a digit is 4 or lower, we don't really round down. I don't like to think of that like that. I like to think of it as we freeze in a way. So we're not going to subtract anything. The only time we need to change a digit is when we need to add one more, when a digit is 5 or higher. So if a digit is 5 or higher, that's going to tell us a number to add one. Okay? So, of course, when we're doing numbers, if we're focusing on, let's just say we want to round this 39 to the tens place. Well, I like to think of it as we're going to go next door. This is what I call the nosy neighbor. The nosy neighbor thinks that he can tell everybody and everything what to do and when to do it, even though it's none of his business. So the nosy neighbor thinks he can tell the 3 what to do. So he's saying, hey, I'm a 9, and according to these rules, the 9 is 5 or greater. So 3, you have to add one more. So I'm going to put a little tiny 1 underneath that 3. That way it's a little easier to see. So 3 plus 1 gives me 4. So we have a 4 in the tens place. Well, the rules for everything to the right of the 3, which in this case is only the 9, has to become a 0. So remember, thank your digits for being a hero, turn them into a number 0. That's what we would do to everything to the right. So I'm going to show you an example of how to use this with a different kind of number. So if we have let's say 35. So 35. So remember, for rounding to the tens place, the nosy neighbor is this 5. He thinks he can tell us what to do. So he is saying, take a look at these special rules down here. Which of these 2 rules applies to me? Well, it would be right here, the 5. The 5 rule tells us to add 1, and we're not going to add it to the 5, we're going to add it to the underlined digit. So the 3 turns into a 4. That's our new tens place. And everything to the right, which would be just 1 digit, turns into a 0. And there are special circumstances, so this rule doesn't always apply. And we'll talk about that in a little bit. We've got those naughty 9s. But for now, let's go into a 3-digit number. We have 932. I want to round this number to the nearest hundreds. So the same rules apply. I look at my 3. He's my nosy neighbor, is telling me what to do. He's saying I'm a 3. I am 4 or lower. So 9, you need to freeze. I don't want you to do anything. So the 9 is going to stay the same. And everything to the right, the 3 and the 2, will both turn into a 0. But what does it look like? We're going to use the same number, 932. What does it look like if we're rounding to the tens place instead? So this time we're going to round to that place right there. Well, we're going to still look next door. That nosy neighbor is telling us what to do. And in this case, the 3 is still 4 or lower. So we're going to freeze that 3. Ignore the 9 for now. We'll come back to that later. Remember, everything to the right turns into a 0. So really, 32 turns into 30. But now we still have this 9. We cannot drop it because it'll change the value of the number. So, in most cases, everything to the left will stay the same. Like I said, in most cases. I'll show you some examples of when it doesn't. So we simply put a 9. So it's 930. So I want to show you a few ideas of, again, I'm going to round to a high, this time I'm going to round to, I'll show you a 4-digit number and show you different ways to round it, and they'll show you the naughty 9. So if I have the number 6,000, let's go a little bit darker, 6,571. First I'm going to round it to the nearest 1,000. So I'll block this in a little bit. So to the nearest 1,000, I'm going to look at this number right here, this digit. Look at my 5. Well, I know that my rules say that if a number that I'm pointing to is 5 or higher, I have to add one more. So I'm going to add one more to my 6, and it turned it into a 7. But then everything to the right turned into zeros, and I have 3 digits to the right. So the nearest 1,000 would be 7,000. Now let's take the same number and round it to the nearest 100. So I'm going to now underline my hundreds place, and my arrow will be pointing at the digit in the tens place. So the 7, oh, that's 5 or higher as well. I'm going to ignore this thousands place for now, but the 7, since it's 5 or higher, tells the 5 to add one more. So it changed it to a 6. Those 2 digits, the 7 and 1 to the right, turn into zeros. And of course, we cannot forget about that 6 in the thousands place. It needs to stay the same. So the nearest 100 is 6,600. So we're going to take this same number again and round it to the nearest 10. I'm trying to use a different color so it's a little easier to tell the difference. But the nearest 10, we underline the tens place. We look at that digit next door. Well, the 1 is 4 or lower. So I know that rule says to, hey, 7, freeze. So I'm going to keep that 7 a 7. And there's only one digit to the right of the 7. So that turns into a 0. So everything to the left turns into, well, nothing, because it stays the same. It doesn't have to change into anything. Now, you remember how I said there are some exceptions to the rule? Well, math likes to be tricky, so I'm going to show you an example a few examples of the naughty 9. So this is when you have a number that you have to, it doesn't follow the rules basically. So let's just say you have a number 995 and you want to round it to the nearest 10. Well, okay, so this looks easy. So I'm going to look next door. Oh, cool. Okay, so 5 tells my 9 to go up 1. So I'm going to add 1. Wait a minute. Well, that's interesting. Check this out. If I add 1 to my 9, I get 10. Watch this. This is what I like to do. I'm going to pretend like it's an addition problem. I'm going to keep my 0 down here as normal. I'm going to carry my 1 from my 10 because I know I can't have 2 digits in the same place value. Now check it out. I have to add again because I can't just have this 1 hanging out with this 9 without adding it. So 9 plus 1 gives me 10. So really, I'm dealing with, and of course everything to the right, the 5, turns into a 0. So really, I'm left with 1, 0, 0, 0, which is 1,000. So let's take another look at an example of something else that could apply to this. We have the number 1,962. And I want to round to the nearest 100. So I'm going to look next door at my 6, and well, the 6 tells the 9 to add 1 more. So I'm going to bring down my 2 placeholders because everything to the right turns into zeros. And then if I add 1 to my 9, I get 10. So I'm going to take and carry to the next placeholder. 1 plus 1 gives me 2. 2,000. And for another example, if you have the number 9,624 and you went around to the nearest 100, I'm just kidding. I'm going to change that, not to the nearest 100, but if you went around to the nearest 1,000, you look next door at the 6, and it tells the 6 tells the 9 to add 1 more. So if you have 600, all these digits right here, 624, turn into zeros. And then 9 plus 1 turns into 10, and you have 10,000.